So page 37, have your calculators ready to go as well, because if you didn't do, do this at home, you're going to have to review how to find all those buttons, okay, using your calculator. Okay, so 37. I just want to emphasize something. If you don't have the scale factor, you need to find it somehow, okay? Then if there's A, like B, C, D, any other questions that flow from it, you just use that scale factor that you've found. Morning. Page 37. One thing that a lot of you seem to be not stuck on, but you're not sure when am I using what. So technically, if you go to 37A, when I did this, when I divided it, I got that, right? It actually was a finite decimal. It ended 708. So I used all of it. But technically, if you were to state it like this, round it to 2 decimals, that would have been correct, okay? Like if you round more than 2 decimals, as long as it's done correctly, that is okay, as long as it's not money, okay? So let's say you had stated that is a scale factor. No problem, 100%. And you use, if you wanted to use that in B, right? So instead of 0.708, you use the 0.71. That is totally fine. Okay, especially if it goes A, B, C. Like if I ask you explicitly for the scale factor, it's okay to round it to 2 decimals there. Okay, so don't be like if you're consistent, you'll be fine. That shouldn't worry you too much at this point. So we figured out, once we had that scale factor, we knew the surface area of the new shape. We wanted to know the surface area of the original, right? So we figured out this here, right there. Okay. So what about C? Determine the amount of ice cream the smaller can hold. That is kind of alluding to volume. And better yet, right, when you think of volume, what are the units associated with this number? It's a cubic unit, right? So right away you're thinking K cubed. You're not thinking just K like we used to do. So you should start your formula like this. Volume of new over volume of original. Like that. Do we know our scale factor? We do know it from the top. We're still talking about the 2 shapes. So I'm just going to use that in here as well. So you go 0.708 over 1. I like turning it into a fraction just so you know what to multiply, what to divide. But don't forget to cube it. If you forget that, you're going to lose 1 mark right away. Okay, so you need to make sure you get that right. Now, this is important. When I looked at your ECs, some of you got the idea right, but you put the number in the wrong place. I know the volume of the original. I want to know the volume of the new shape. Okay, so this is unknown to me, and the 2454 cubic inches stay. Okay, so that's a setup. That would be a 1 marker right there. And then take your calculator and you go 0.708. So you cube the top number, you cube the bottom number. That's how it goes. Okay, if you have a fraction, you do it separately. Oops. All right. And here's where the rounding comes in again. So here you have to be careful. You're still working through the question. So I would do this. 37. I would just do that, you're telling your audience I'm using all decimals. And then this is volume of new, and this is 24.54. And now that you cubed everything here, you can cross multiply and divide. And remember, the only units are cube units in this case. So you cross multiply and divide. The volume of new is 2454 times 0.354, and that keeps going. Oops. And then you divide it by 1. Not really necessary. I'm not going to type that in. It's just so we stay consistent, right? So I grab my calculator and go 24.54 times, copy, paste, and there you have it. Now you are ready to answer. So that's 0.9 something, right? That will round to 0.71. And we are in cubic inches, right? And so that's how you do a question like that. So we figured out the scale factor right at the beginning, and then we just carried it with us throughout the other questions, all right? So now we're gonna, so it always comes back to make sure you pick the right formula, right? You hear what I'm saying? Pick the right formula. If it's k cubed, don't just, some of students do this perfectly, but they somehow don't even bother with the next step. No, it's very important actually, or else you get it wrong. It's like converting cubic yards to cubic feet just using 1 yard has 3 feet. It doesn't work, okay? But let's go to the top here. How did it all start? I found my scale factor just using K, because all I was comparing is the diameters. These are linear units. It's one-dimensional. Inches is just has a 1 as a power. We're not even bothering writing that down. So I didn't have to root. I didn't have to do anything like that to figure out my scale factor here. I just had to divide, and boom, I got it. Okay. Let's go to 38. That's where things are going to change a little bit. Go to 38 with me, and then I'm going to ask you to try some on your own. Okay? All right. Scale factor from 3D values. Okay. It's going to be the same for two-dimensional. Coca-Cola has made a new larger pop can. The original can is able to hold 355 milliliters and requires this much centimeters squared of aluminum to produce, while the larger can is able to hold 500 milliliters. So one thing to remember, I don't know if you remember this from 1 milliliter is the equivalent of 1 centimeter cube. Maybe that's something I should have. So it's basically saying 355 cubic centimeters. It's the same thing, but usually a can will be in milliliters, correct? Like if you ever buy a pop can, it's 355. So that's the same thing. It still talks about volume. Okay, so now determine the scale factor used to create the new can in these 3 formats, if possible. Okay, so what do we have for both of them? The only thing we have, like if you wanted to use the height, you can't because this is missing. Surface area, you have one of them missing, but look at that. Volume, you have both of their volumes, right? So we will use this, use volumes to find K, right? That's what we're going to do. And that is cubic, right? So you got to start with this one. Volume of new over volume of original. So do we know K? We don't know what it is. So we got to keep it like that. We know the volume of the new one, which is 500 milliliters, and the volume of the original is 355. Beautiful. They're going to cancel out. That's what we want for our scale factor. And now what? Now we need to cube root, right? Cube root, not square root, because of this. So you want to cube root both sides. So we always do the same thing to both sides. Maybe some of your teachers used to just drop the 3 and just have the cube root show up on the right side, but this is really what's happening. And so to show this, we say this 3 cancels with that 3 over there, and then you're left with K on its own, which is exactly what you want. And then I will show one extra step here. So you grab your calculator, strongly suggest to go 500 divided by 355. So this is what's inside the root. And now you cube root. Do you remember how to do that? Math. It is very annoying. Trust me, I don't like that feature. But and then I copy that in. And so that would be my answer as a decimal. If you want it as a percentage, don't times this by 100. You multiply what's on your screen by 100, and then you round it to 2 decimals at that point. Both of them are correct. Can you do this as a fraction? I didn't even try this. You can go math and then hit fraction right next to the answer. It can't, right? So it just keeps it the same way. So So in this case, just leave it like that. If you can't do the fraction, in fact, if this throws you off, just get rid of this. Like I would have checked it ahead of time on a test, and I wouldn't ask you if you can't do it. Okay. But technically, we'll just leave it like that. We're good. So now you have your scale factor. This is huge. You have your scale factor. Now you can answer other questions that are missing between the two. All right? So calculate the amount of aluminum required to produce the larger can. And so we're talking surface area. So aluminum, we're talking surface area. We're talking K squared, correct? It's going to be K squared. So I got to start with that. K squared is equal to surface area of the new over surface area of the original. Got it? We already know the scale factor, correct? We found out what it was up here. That is what I'm going to use here. So I'm going to take that, I'm going to go 1.12 over 1, square it, and I know the surface area of the original. I don't know the surface area of the new. And that's what the question is asking anyways. What is the surface area of the larger can? And this is 322.57 centimeters squared. As soon as you write down centimeters squared, you should realize, oh, wait a minute, I should square my scale factor. I can't just keep it, right? I can't just use 1.12 as is. I have to square it. So that's another thing to watch out for. I'm going to highlight that part. As soon as you see that, you should be like, oh yeah, I got to match that by squaring it. You grab your calculator, you square it, square this. That's 1.2544. Because it ends, I'm just going to write down all of it. Over 1. And then surface area, 322.57 centimeters squared. And now you just cross multiply and divide. Okay, so surface area is 322.57 times 1.2544 divided by 1. There we go. And I have this on my calculator still, so I'm just going to go this, multiply by 322.57, and there you have it. It should be more, by the way. You should have a greater surface area because it is a larger can. Okay. There you have it. All right. And if my key or anything ever mentions textbook, just ignore it, right? So try this one in the textbook. Don't worry about it. I no longer give out textbooks. C, determine the height of the larger can. If you're talking height, is it one-dimensional, two-dimensional, three-dimensional? Just one-dimensional, right? It's just length or height or something. So this is just 1D, so it's just K. That's it. So you use this one. K is equal to, we can do height of new, height of original. Why are you using new and original, not diagram actual? Just because for me, right now, that's easier to relate to. I have my original can, I made a new one. If it says blueprint, picture, anything like that, I use diagram actual. Like I think of, this is the actual thing, and I made a smaller version of it, right? So, do we know the scale factor? You bet. It's 1.12. Hasn't changed. Over 1. I know the height of the original, correct? Right here, 12.2. And so I'm just going to figure out the height of the new, like that. Again, so the cross multiplying, dividing is always going to be there. When you have your scale factor, you're going to have to figure out one of the missing dimensions on the right side. The problem is, do I need to square it, cube it, or do I need to do something about it before I cross multiply and divide? So K is equal, oh sorry, not K. H new is equal to 12.2 times 1.12 divided by 1. And I'll just give you the answer. That's 13.66 centimeters. There we go. Now, I think this is all I assigned, correct? Or I may have gone further with the key, but I'm pretty sure this is all I assigned. I went to 39, but I don't think the key was up, was it, for 39? Okay. So I'm gonna put it up shortly, but I need you to spend some time on your own figuring this out. So I'm gonna say 39 to 41 for now. 39 to 41, you work on your own or with your neighbor, but as long as it's quiet. As long as it's quiet. Let me give you a little hint with 41. Go to 41 real quick. I know you might not believe me, but this is exactly what we've been doing this whole time. It's just in a table. Where is your original? Right there, I told you that. You know how else you know if I didn't tell you that? The one that's completely filled in is your original. Then you're going to think of original, and you're going to make a new shape here, the first one. You're going to fill that in. Then ignore it. Once you fill that in, you ignore it. Then you're going to compare the original to this new one that you're making here. Okay? You fill that in, you ignore that. And you go original, you make a new one here. So you're making 1, 2, 3, 4 different versions of the original. So that's what you're doing there. I'll let you figure that out on your own for now. I'll just give you one hint. What is the first thing you should find for every empty row? Scale factor. How would you get the scale factor here? You would use, the radius would give you the scale factor here, and then figure out the area using this area, right? Volume using this volume. And here's where I'm going to give you the shortcut one more time. Remember, new is always equal to K times original. That's what I would use to make it a lot faster. You know what? I feel like I should probably be specific. If it's surface area of new, what would you do? K squared times surface area of original. If it's volume, you got it, right? Volume is new is K cubed times volume of original. If you need to have these on somewhere on your study sheet, because all of these are going to be new ones, right? New measurements. So you basically take your original, multiply it by K squared to find this. Take the volume of the original, multiply it by K cubed to get this. So it's a lot faster once you have your scale factor to do it that way. Anyways, I'll come and see you. I'm okay with you asking tons of questions, but 39 to 41, okay? And try to stay on task, try to stay focused. So if your neighbor is a distraction, then maybe tell your neighbor, talk to you later. Okay. Not right now. I'm going to make another note. Hopefully this is going to help you. Okay. So maybe just look up here for 10 seconds. Okay. I know you're wanting to finish. But the question is, when do you square root? Right? And when do you cube root? Like, when do you do the rooting and when do you do the just squaring or cubing, right? I think some of you are maybe not quite sure when to do what. If you're trying to find the scale factor, right? If you're trying to find, you want to find what this is. You have both numbers on this side. And they're both areas, for example, right? Then we know it's K squared. So before you're done, you have to square root both sides, right? To get your scale factor. Look at page 39, this example here. I had both volumes. So I know that if I'm comparing volumes, I have to have K cubed here. So before you're done, you're going to cube root both sides. So if you want to find a scale factor, I'm not saying you're always going to have to, because if it's just a linear dimension, you don't have to root, all right? But if you notice that it's K squared, and you have both numbers on this side, Or if it's k cubed, and you have both numbers on the right side, you're going to have to root, either square root or cube root, depending on the situation. Okay, so that's the only time you root. If you have the scale factor, let me show you here, page 40. I'll show you here a cargo container, right? That's page 40. If you have the scale factor, it's given right there in this case. You still have to set it up like this, but you're given the scale factor, so what do you do in this case? You actually do what it says to do with the scale factor, which is put it in there and then cube it. So if you have the scale factor, you're not going to have to root. All right, guys? You're not going to have to take the root of anything. Continue. In a bit, I'll do that table with you guys so you know what to do, okay? If you're still stuck on that, just wait for me a little bit. So everybody go to 41, okay? I know you're working. I'm going to stop you what you're doing right now. Go to 41. I'm just going to do this in a systematic way. We're first going to find the scale factors for all of them. I'm not going to do anything but the scale factor because that's the important part. Okay? So if this is my original, right, this is the one that everything is going to be made out of, right? So original and the first one, let's say. How do I find the scale factor here? I'm just going to go new over original. And what is that? Some of you figured that out already. 0.18. You got it. No rooting, right? We don't need to square root or anything, right? Because it's just taking the radii and dividing it. Boom. Moving on. Let's do this one. How would I find the scale factor here? The only two things I have for both of them is the area, surface area. So I need to go k squared, correct? I hope you get that part by now. What's the new? It's 254.74. Sorry, 47. My bad. And then it's a 706.86. And what do you have to do in this case? I have to square root, that's right. And because space is limited, I will just show this, that we're square rooting. And some of you are still, you need to start just getting used to this calculator. Some of you are still hanging on to the one you've been using all along. That's fine, but it's going to be tedious always going back and forth. So I go 254.47 divided by 706.86. That's what I do. And then I press second x2. That calls the root. Okay? And then I just go up with the arrow, copy it in there, and then enter one more time. So that's your scale factor there, 0.6. If you want to add another 5 zeros, go for it, right? Not going to hurt you. So we found the scale factor there. I think maybe I'll just stop there. This is the key, finding the scale factor. And here's the shortcut, guys. Watch. Fill in the rest. How would I fill in this area? I would go k squared times the area of the original. What is k? It's 0.18. Times, what's the area of the original? You can do the setup, cross multiply and divide if you want. In fact, I can tell you this on a test, if something like this shows up, I leave you lots of space to do it. But this is the shortcut. Once you have your scale factor, just square it and then just go 706.86. Then grab your calculator and just go 0.18, press the x2 button, and then multiply it by 706.86. So that is your new area, and it's squared inches because we go off of what we have to begin with, right? There we go. What about the volume? K cubed times volume of original. That's what it comes down to. If you want to find your new stuff, just go K cubed or K squared or whatever times the original. So we go 0.18 cubed times 1767.15, and that's cubic inches. So this is how you do it on your calculator. You go 0.18, use that little hat button. It's underneath clear, and then just go 3. I would go arrow sideways to bring it back down. Don't be adding more to the exponent. Then you just go times 1767.15, and there's your new volume. 10.31, correct? Boom, you got it. So the key is find the scale factor, then move out to the sides and fill in the rest. For example, the second one, the scale factor is 0.6. How would I find the new radius? It's just K times radius of original. It's just 0.6. You're not squaring. You're not cubing. None of that. Okay? You just as is. So 0.6 times 7.5. That's 4.5 right there. Okay? So once you have the scale factor, you may have to square root or cube root. It depends. And then you move out to the sides. Smile, guys. Life is okay. I know sometimes it's a little strange. What about this one? How would I find this one once I have the scale factor? I'm not even going to show you the, I'm just going to go 0.6 what? It's volume. Cube. Times 1767.15. I appreciate you guys whispering that. Yeah. And so, right, you just grab your calculator, 0.6, hat 3, bring it back down, 1767.15, and there it is. And by the way, I hope you know that if K is less than 1, it's a reduction, correct? So it should be smaller than the numbers you have here. If that's not happening, go back to the drawing board, start over, okay? So I'll leave the rest. The key is posted, so it kind of shows you if you're stuck. Look at number 4. The scale factor is already there. Easy peasy, right? You don't even need to find it. And then the 5th one will be a bit more work because watch, you have both volumes. How are you going to find K? You're going to have to take the cube root of their volumes to figure out K here. And then you move out. Okay? So watch what it says down here. If you want more table work, write this down, 51 to 52. I'll say this, 51 is basically the same one. I forgot to change it. But if you're like, you know what, Mr. Dirksen did one with us, sort of. I want to know if I can do this by myself. Try it one more time on page 51. 52 is brand new, right? So you can try that there. All right? Keep working.